Hey everyone, and welcome. Let's talk about the software you use every single day. We're going to pull back the curtain and look at the hidden architecture that separates an app that just works from one that's a total pain. This is the blueprint for building bulletproof software. You know the feeling, right? You're right in the middle of something important, checking out online, sending that crucial email, and bam, the app just dies. It's so frustrating in an age of incredible tech. How is this still a thing? Well, here's the thing. It's usually not just some random glitch or bad luck. More often than not, it's because the software is put together without a solid plan. I mean, you wouldn't build a house without a blueprint, right? The same exact thing goes for software. So, in this explainer, we're going to walk through that very blueprint. First up, designing with tests. Then, we'll get into automating, well, almost everything. After that, we'll talk about measuring what really matters, and we'll wrap up with the art of a good bug report. Let's jump in.
Okay, first things first, designing with tests. You can think of this as drawing up the architectural plans. Before you even think about laying a foundation or, writing a single line of code, you have to define exactly what a successful build is going to look like.
And the most fundamental part of those plans? The unit test. If our software is a building, a unit test is like checking every single brick to make sure it's solid and perfectly formed before it ever becomes part of a wall. From there, we get this really powerful idea called test-first development. It's a total flip in the usual way of thinking. Instead of building something and then testing it, you write the test first, a test that will fail until the feature is built perfectly. It's like deciding how you'll measure success before you even start. And test-driven development, or TDD, takes that concept to the next level. Here, the test isn't just a check, it actually becomes the specification that drives the code's design. The only reason a developer writes a piece of code is to make that one specific test pass. It forces you to write only what's necessary, which leads to incredibly clean and efficient software. And finally, we can zoom out to acceptance test-driven development. This is all about the user's experience. These tests are written in plain language, describing what should happen from a customer's point of view. For instance, when I put an item in my cart and hit checkout, I should land on the payment screen. This makes sure the final building isn't just structurally sound, but it's also exactly what the client, the user, actually wanted. So, we've got our architectural plans. Now it's time to actually build this thing. And in modern software development, our power tools are all about automation. We absolutely should automate all the heavy, repetitive stuff. Unit tests, integration tests, performance checks, these are perfect for a machine to run thousands of times without getting bored or making a mistake. But, and this is a big but, you can't automate everything. That's where a human eye comes in. For something called exploratory testing, you need a creative person to just poke around, try weird things, and find those strange bugs that no automated script would ever think to look for. All right, our project is well underway. The walls are up. Now it's time for the inspector to show up with a clipboard. In software, our inspection comes in the form of metrics. Now, one of the most popular metrics you'll hear thrown around is code coverage. A team might proudly announce, "We have 95% code coverage." And on the surface, that sounds amazing, doesn't it? Almost every single line of code is covered by a test. But wait a second. We have to be smart about this and ask, what is that 95% really telling us? Does it actually mean the software is high quality and bug-free? And here's the trap. That number can be a huge lie. All code coverage tells you is that a line of code was executed during a test. It says nothing about whether the test actually checked if the code did the right thing. You could have 100% coverage and still miss tons of bugs. It can give you a false sense of security while completely ignoring the most complex, riskiest parts of the application. So remember, coverage is a tool, not a goal. Okay, last stop. The building is basically done. This is the moment where you do the final walkthrough and create a punch list. That little list of final tweaks and fixes. For us, that's the bug reporting process. And trust me, the way you report a bug can make all the difference in the world. A bad report is just noise. It's vague. The login is broken. It might even blame a developer. A good report, on the other hand, is a tool for problem solving. It's specific, it's objective, and it gives a developer a clear roadmap to find the problem and fix it fast. So what's the anatomy of a great bug report? It's really simple. You need a clear, specific title. You need the exact detailed steps to make the bug happen again. State what you expected to happen, and then what actually happened.
And finally, include proof, like screenshots and the software version number. This is the difference between a bug getting fixed in an hour versus languishing for weeks.
So as we wrap this up, it becomes pretty clear that building amazing, reliable software isn't magic. It's not about finding some genius coder who never makes mistakes. It's all about having a disciplined process, a blueprint, that combines smart design, intelligent automation, and really, really good communication. And that kind of leaves us with one last question to think about. The next time you use an app that works perfectly, or more likely the next time one crashes on you, just ask yourself, the software you rely on every day, was it built with a blueprint? Thanks for tuning in.